So in case you didn't watch the video, Mac, we're on question 11, I think. 12, sorry, we're on 12. Somebody's
12,
echoing.
Unit 4.
Yes, Tanner, you're echoing.
Let me open that. Oh, my mic. Well, I don't know what you said.
Okay. So there really isn't much of an option other than to write a volume equation. If you look at the triangle I have on the board, it's an isosceles right triangle. So if you cut it in half to create the height, which is what we need, then you realize that all three of those values there are h. So the area of that triangle, which would form the base, is up in the top right corner. It's 1/2 times h times 2h. So area is equal to h squared. Plug that into your volume formula, because then volume is then the area of the base, which is h squared, times the length, which is 9. So you get 9h squared. Take its derivative. However, when you take the derivative, you get the dv, excuse me, the dv dt equals 18h dh dt that I have on the board. You realize you need an h value, so I went over to the left, made it, figured out the h value, because if you're 2 minutes in, the volume would be 4. Find your height value. Height is 2/3. Plug everything in. Okay, so like I said, I know that one's definitely not the simplest one, but any questions on it? Alright, take that as a no. Alright, 13.
Easy.
Everybody else agree? Easy? No problems?
Yep. Yeah, I'm good.
Okay.
Yeah, Mom!
Don't be mean.
I wasn't mean. I just said, yeah, Mom.
Jack is being sassy.
That's not mean. That's sassy. There's a difference.
Hateable.
Number 14.
Oh, I need it.
Okay. Local linear approximation differential function is used to approximate the value of 2. The approximation is an overestimate.
I remembered like using LRAM and RRAM to do over and underestimate, but I wasn't sure if linear.
It's pretty much the same way. So you have to ask yourself, um, the increasing, decreasing, and the concavity are the two ways you're going to look at that. So if I'm using a line, that means, because it's a linear approximation, and it's an underestimate, that means if I draw the line at the point x equals 3, and I go to 3.2, it will be under the curve. Or sorry, over, because it's overestimate, my bad. I didn't read it all the way. So it'll be over the curve. So obviously A, that's not true, because it's actually the curve. So A is exact. If you were to draw the line on B, would that be under or over the, excuse me, under or over the curve at 3.2?
Under?
It'd
Maybe?
be, it would be under, because if you just think about drawing a tangent line, it's going to be under it. What about for C?
See, C is the one I picked, but because in my head 3.2 was above 3.
It is above 3, but you have to ask yourself the tangent line, basically. Remember, a linear approximation is a tangent line. So would the tangent line on C be above or below?
Wouldn't it also be above?
Mm-mm. Think about what's happening to the curve. The curve is getting
Oh,
steeper. The tangent line would stay the same steepness. So would the curve be above or below the tangent line?
below.
Right. Oh, no, the curve would be
So,
above. The tangent line would be below. Make sure. I think that's what you meant.
yeah.
But then when you get
So
to
you
D,
need to. So it needs to be concave down.
In this case, yes, because we need the
Okay.
tangent line to be above the curve.
Gotcha.
Yeah. So anytime you talk about the underestimate, overestimate thing, you always want to ask yourself about increasing, decreasing, and concave up or concave down. Those are the two things you got to ask yourself. For this type, we don't need the increasing, decreasing part. We just need the concavity. When you start talking about the approximations in the LRAM and RRAM, then you'll want to think about both the increasing, decreasing, and the concavity.
Alrighty.
Okay, 15.
Never mind. I thought it said overestimate, so I chose C. Because I was just thinking of that.
I'm trying to think if I had to guess on this one or not. Oh no, I didn't.
So again, same idea here, just in case. So since it's underestimate, that means you would need the graph to be concave up.
Yeah, I'm good.
So D. 16 should be pretty easy for you guys. We do remember our indeterminate forms, yes, just making sure.
Can you explain each answer? I got it right, but I was like one or two. There was one I couldn't choose. It was like right or not.
So on A, clearly top is 0. Bottom, you have to know what cosine of 0 is. It's 1, so 1
Yeah.
minus 1 is 0, so you get 0 over 0. B, if you try to plug in, oh, it's 3, not 0. If you plug in 3 on top, you get 1. Ln of 1, so ln of 1 is 0, in case you don't remember. You gotta remember that's a fact,
Yeah.
we gotta know. I'm assuming on the bottom you get 0 if you plug that in and do all that.
You do.
Obviously C, you get 0 on top. However, sine of 2 pi is not 0, or is not 1. Sine of 2 pi is 0. So you get 0 minus 1 on the bottom. That is not an indeterminate form.
So you get 0 over -1, which is 0.
Correct.
Not indeterminate.
Yep. And then for D, obviously it's infinity over infinity, because infinity to the 10th is infinity, and e to the 2 infinity is infinity.
Yeah, that's the one that I wasn't sure. Like I was going back and forth with.
Yep, that one will be infinity over infinity.
Well, isn't the top a Z? Or is that an X? That's
That's
an
an
X.
X.
For a second I thought it was a Z and I got really confused. Never
Yeah,
mind.
they won't mix variables like that in pretty much anything. Alright, 17. Shouldn't give you guys too much trouble. Anybody need me to go over 17?
No.
I'm going to take the silence of the other 4 of you to mean that you don't need me to go over it.
Who is Quasimodo?
Who's
Max.
the only other person in here, Mac?
He's not saying anything.
He has not spoken once since we've been doing this.
You should fail him.
Should fail him. Number 18.
Yeah, I missed that one. I don't know why.
Okay. I'm assuming it's going to be a L'Hopital's rule just based on how they've set the question up, because they've given you both f of x and the tangent line. Once they give you a tangent line, that means they're probably asking you a derivative thing.
I figured.
So if you try to use, just plug in the 0 idea. Let's see, what do we get?
I think that's what I did. I think I just plugged in the 0 and I got 0.
No wonder I couldn't figure it out. I was trying to plug in 2.
So you get 2 times 1 minus 2, 4. Yeah, you see, if you try to plug in 2 or 0, you get 0 minus 0, or 0 over 0. So that is L'Hopital's rule. So you just gotta use take the derivative of both the top and the bottom. So hold on, that's probably where it made some mistakes. So I'll do that out.
Yeah, I forgot about product rule as a whole.
That would not be good.
Wait,
So
so
So it's f of x e to the negative x minus 2 over x squared minus 2x, right? I think. Okay. So derivative of the top, remember, don't do quotient rule. Just do derivative of the top, so you get f prime of x e to the negative x plus derivative e to the negative x is actually negative, so we'll have a minus there. Minus f of x e to the negative x over 2x minus 2. So you get that when you take the derivative of both the top and the bottom. And then plugging in your 0. So this is why you needed the tangent line. This is why I assumed, like I said, it was going to be L'Hopital's rule. So if you plug in 0 to f prime, you get negative 2. So I get negative 2 times 1 minus 2 over negative 2. Negative 4 over negative 2, which is 2.
Oh, hey, Mr. O'Donnell.
Yes, ma'am.
Miss Barris just posted in the Ace English little discussion board or whatever. She said that Friday class discussions at 9 a.m. are mandatory.
Okay, we'll work around it and talk about it.
Where can I get some colorful headphones like that?
Mine from Logitech.
Where?
Logitech.
Where's that?
It's a
Hey,
brand.
Mac, you need some colorful headphones.
Anna, did you say that was on Friday?
Yeah, she said on Fridays it's a mandatory 9 a.m. Zoom, I guess, to like talk about what we read over the week.
I don't know if you're allowed to do mandatory. Just to throw that out there. But, I mean, I'll cancel class on
What
Fridays
the
for you guys. I don't
hell?
really care, but...
She posted at 8:42 a.m. I will be on Zoom at 9 a.m.
Well, that's for like questions if you have it.
Right, but what if you already
And
had plans?
Yo, yeah.
Tuesdays and Thursdays are not mandatory. Oh, so she only does a Tuesday, Thursday, and Friday?
yeah.
I told you that's what most teachers will be doing. They'll be doing like every other day type things and stuff like that.
Is Tuesdays and Thursdays like a class thing? Is she
Doing
teaching?
our reading and our class discussion like board post every single day.
Yeah, I don't know. I don't mean, that's fine. I can work around that. I didn't know any other teacher was doing anything like that, so I would have talked with her. Like I said, so no big deal. Whatever. I'm not worried
Wait,
about
quick
it.
question.
Yes, ma'am.
Good.
Are the things, this is you would know, things on Tuesdays and Thursdays like class, or is that just if you have any questions, you just get on like, hey,
Just if you have any questions.
okay, good. 'Cause I just don't want to miss anything.
You just have to be on the Friday one.
Yeah.
Okay. Moving on to FRQ Part A that only 3 of you looked at.
I couldn't get
So-
past part A.
I did not do well on it. I got like, I didn't,
Oh, we're
also,
supposed to
quick
get information
question.
from Ace today. I wonder if they put it out yet. Go ahead.
Anna Rudek, sorry, I should just text these questions, but we're on here now.
Yeah,
I
you're
tried
fine.
to turn in something for Chautauqua yesterday because we still have an assignment due today, and there was no like button to like submit an assignment on Canvas.
Well, I didn't even know we had one due, so
Well,
thank
it's
you.
been there for like it's one of those that's like been there for a while, and I just assumed they were still due. I don't know.
I'll have to look at it.
If not, do you know her email?
It's somewhere on here, on Canvas.
Okay. Anyway, so FRQ,
There's not as
I
much of a reason to do it if only 3 people have even looked at it.
oh
Well, can you just do part A so I know how to start it because I couldn't go any
Yeah.
further.
I can look
I
at
could
part
do
A. Hold on.
D, but I couldn't do any of the other ones.
Okay, so that's all there's to set up. Okay. It's the rate in, rate out questions.
Yeah, but how do you
Right.
combine, like, do you have to combine those formulas? Or,
Depends on what they're asking for. Are they asking
well, it
for
looks,
the, well, hold on, you gotta think yourself. Are they asking for the number of people coming in? That's the rating question. Are they asking for the number of people leaving? That would be a rate out question. Or are they asking
yeah,
for a total amount of people
they're looking for
in there?
the number of people.
So you have to take into account both the people
Total.
leaving and the people entering to get a total rate question. So you
Yeah,
got to
what
think
I
to
did,
yourself, you need to figure out how many people are either coming in or going out in total, and that's going to take into account both, in this case, A of T and L of T.
yeah, that's what I did for part A. I took the number of people coming in at that time, people leaving, subtracted them, got a number.
That would be the rate. That would not be the number of people there. So they want to know
Okay.
how many people. So how do you figure out an amount with a rate in, rate out question?
Well, they give us that P of T is the number of people at the venue at T hours.
Yeah, but we don't have a function for it, though. You have to write your own function for it.
Yeah, and I don't know how to write that.
That's what we're trying to figure out. That's what I'm saying. So if they give you A of T, which is the number coming in, I assume, arriving, yeah. So the number of people coming in, and per hour or whatever, per whatever they're using, they don't say. I'm just gonna say I want to assume it's an hour. So the number of people coming in per hour, and then L of T is the number of people leaving. It is hundreds of people per hour, yeah, per hour. So how do you figure out the total number of people in the venue? Remember,
You
you
have to
have.
do integrals then?
Why would you have to do an integral?
I don't know, because you said my value was a rate. So,
That's the thought there. So,
So
yes.
I tried to subtract the integrals and I still couldn't do it.
Also, why would they have you do integrals here? Maybe they just put this question in the wrong place. But A is definitely an integral. There's like almost no way it's not, unless I didn't read the question all the way. I'll pull up the answer key. But it should be an integral.
Definition define 2.5 though.
Okay, so
Which I could do.
oh, you're using it to approximate. You're basically writing a tangent line.
SCC?
No, you're writing a tangent line. I didn't read the part where it says approximate. My bad. So anytime that you're using that word approximate, you're using a tangent line, a linear approximation. So they gave you the x and the y, which is 2 and 6. And then what's the only other thing you need to write the equation of a tangent line? How do you find
Slope
it?
point.
Okay, so how would you find the slope of p of t?
It's A of 2 minus L of 2.
Right. So you have to realize that p of t, the derivative of p of t, is just a of t minus L of t.
wait, I think I mean, I don't know if I did this.
Yeah, so that's a
I
little
may,
wonky. You probably never see a question like this where it's just because you're just using a of t and L of t. But it's possible, I guess.
also, my point, I used 600, but is
Mm-mm.
that not right?
It's 2-6. The people are measured in hundreds. So since there are 600 people, that means your value would
Okay.
be 6.
Hold on, wait. So that would make sense because I had that P of T was the integral of A of T minus the integral of L of T. So you just took the derivative of the whole thing.
Right, because you need yours is 100% correct. So again, sometimes since we know a little more calculus, it makes some things a pain in the butt.
So we don't do anything with integrals?
Not yet. There's just unit 4 still derivatives. So we
Because,
know
yeah.
that p of t is. Let me minus L of t at 0. Sorry, hold on, because you got to be careful, because nobody's leaving from 0 to 1, isn't that correct?
Correct.
Yeah.
Correct.
Yes. So it's
So that's why I had the
actually,
bounds different. So I didn't know
yeah.
how you can.
So we're looking at 2, so we could do from like 1 to 2, or 1 to t, not. So this would create a kind of a weird situation going on where it's going to be hard to write an actual equation. So we're looking at this would be like kind of your function for our problem, and we need p prime. So if I go to do p prime of t, you would get a of t minus
You
L of
need
t.
P prime for
Because you're writing a tangent
A?
line, a linear approximation. They're
Oh.
very, very vague on telling you that it's a linear approximation. But it's actually no. It says write an equation for the local linear approximation and then use it. My bad. I did not read the whole question at all. It's apparently either really early or I'm just being a moron today.
Well, I mean, I read that and it didn't do anything for me. So
I didn't
Wait,
read
what?
that at all. It says write an equation for the local linear approximation. So in other words, you're writing
I had
a
to
line.
Google what a local linear approximation was.
It's just a linear approximation. Remember, we talked about this. What happens to your line and your function as you move further away from the point you used, usually?
Yeah, what I did is I wrote like a point slope and then I plugged in 2.5.
That's
Is that
exactly what you
wrong?
should do.
Okay. Well, my equation was definitely wrong because I, had 600 in it, and my slope was 0.40148416.
Your slope's correct.
Really?
Yeah. Because you just got to get to the realization that p prime of t is equal to a of t minus L of t after 1. It's very important.
I definitely, yeah, I got that value by just
Yeah,
subtracting a of t from L of t, but I didn't know that was P prime.
yeah, it is. So I will warn you, always, always, always be careful to look for things like from 0 to 1, nobody leaves. That's huge to writing the answers to these equations. A rate in, rate out question, I would say even with the new stuff, there's going to be something to do with that. That's a huge thing because it uses so much calculus. There's derivatives, there's integrals. You could use FTC. You could use the mean value theorem. There's all kinds of questions. So I would highly suspect there's going to be some sort of rate in, rate out question because it just uses so much calculus. That it's a question that can combine a lot of topics. So always be on the lookout for that little part where it's like, oh, for 0 to 1 it's blah. Or if you remember the banana question that we did last year and the year before, you guys didn't do the potato cooling question, I don't think.
I remember
You gave
we
it.
took
It was like number 3, I think, for
Yeah.
one of them.
So like there's certain questions that are there, so it's a differential equation. I would assume there's probably going to be a differential equation question at some point you'll have to do
So
something
will
with
you
it.
write out the final thing
What final thing?
for part A, the linear approximation?
The number, or do you want the
Like
line?
the line.
Yeah, I can do that for you. So remember, your fancy formula is just equal to this. So we want to solve for y basically. So our slope is that 0.484 number, whatever it was, x minus, what was it, 2 plus 6. So there is your linear approximation. Now they obviously used different things like L of x or P of t or whatever, but that would earn you full credit. They use t's, so I mean you probably should use t's mostly. I mean, but y's and x's are perfectly fine because there's technically no y anywhere in this stuff either, and they used a y, so using x's for a linear approximation would be perfectly fine as well.
Okay. And the 0.484 comes from plugging 2 into P prime T?
Yep, because you're writing
2.
the linear approximation at 2. And
Was
the
this a
local part,
calculator one?
yes.
Okay.
Yeah, you're definitely not plugging in those values into sines and cosines and stuff. And again, the local part is just saying that it's only useful for around that. It's just verbiage. Basically, they just want you to write a linear approximation.
All right. That's not bad.
Yeah.
So do you want us to do A and B, like FRQ?
You mean both parts of it, like the part A and part B?
Yeah.
Yes, please.
Okay.